Hello and welcome to EGM722, Week 1, Part 5, Controlling Flow. In the first lesson, we introduced the concepts of expressions and statements. So an expression is just some combination of objects, variables, and operators, while a statement is an actual unit of code that the interpreter can execute and have the computer actually carry out. So when we're writing our program, we're writing the program as a list of different instructions or a list of different statements. But we usually don't want to write the program in such a way that every single statement is carried out exactly in that order. We might want to have our code executed where we have some section of the code repeated, or we might want to skip certain sections of the code depending on the status of the different variables in the program. And so that is something called flow control. So controlling the flow or the order in which the different statements are being executed by the interpreter. And that's what we're going to be discussing in this lesson. Before we get there, I'm going to talk about Boolean expressions. So a Boolean expression is just an expression that evaluates to either true or false. So for example, we can have a variable called meaning of life, and we're testing here whether that variable has a numeric value of 42. We might also test whether 1 has a value of 0. So in this example, the double equal sign here is an operator. It is a comparison operator that is testing whether or not the two different objects on either side have the same value. So it's true if the left side and the right side are equivalent, and if they are not true, then it returns a value of false. So in this context, true and false, written in this way with a capital T and a capital F, are values of type bool. They are Boolean values because this is Boolean expressions and Boolean algebra that we're working with here. So we can have a number of different comparison operators. We've already seen one where we're testing whether x has the same value as y. We can also have a not equal, where we're testing whether x doesn't have a value equal to y, so it returns a value of true if they are not the same, and false if they are the same. We also have greater than or equal to, less than or equal to. And in all of this, just remember that the single equal sign, like this, is used for assignment only. It's not used for comparing the two values. That's what the double equal sign here is for. We can also talk about something called logical operators. So these are operators that compare two different expressions. So for example, if we have an expression A and an expression B, then the AND operator returns a value of true if both A and B are true. If one of them is false, then it returns a value of false. We also have OR, where this can be read as A or B. So this returns a value of true if either A is true or B is true, or both of them is true. If both of them are false, then this will return a value of false. And the last one is not A. So this returns a value of true if the expression that it's evaluating is false. So in general, A and B should be Boolean expressions, but any non-zero value, as you can see here, is interpreted as true by the interpreter. So that's something to keep in mind because it can cause some problems if in certain contexts. In general, when we are writing or when we're using these logical operators, we're going to try to make sure that these are actually Boolean expressions that we're evaluating and not just testing non-zero values. So the first type of flow control that we will talk about is something called a conditional statement. So a conditional statement is something that executes the code after it if the statement is true, and if the statement is not true, then the code is not executed. These are written in a way that we have something called a header, which is typically the first line of the conditional statement. So we have if x greater than 0, and then a colon. That colon is what ends the header. So we can have more than one line in the header, but it has to end with this colon symbol. We then have something called the body of our conditional statement, and this is indented. So it has to be indented one level from the, so one press of the tab key from our if statement. This needs to have at least one statement. So here we have print x is positive if the value of x is greater than 0. We can use a placeholder called a pass statement, which just does nothing. So when you're writing your code or when you're developing, you can use this pass to help kind of keep place of things if you're not ready to add things into your different conditional statements just yet. But you can see here I've defined a function, which we'll talk about in the next lesson, that takes in a value, or takes in a variable x, and if x has a value greater than 0, then we print a message x is positive to the terminal. And so you see here is positive of 2 returns yes, x is positive. Same for 1,000, but then we have a -1 and nothing happens. And that might not be what we want. That might not be what we want. We might want to know, for example, if x is negative here. So that leads us to something called alternative execution. So alternative execution is where we're doing different things based on some condition. The simplest way that we can do this is with an if-else statement. So we first have our if statement, which says if x greater than 0, then print this, followed by an else statement, again, which has a header, which is just else, a colon. It's then indented with our single line in the body here, which just says print x is negative. And so you can see the results here. We have, yep, x is positive if x is 2, x is positive if x is 1,000, x is negative if x is -1. But that's kind of weird because 0 isn't really negative or positive. So the way that we've defined this, the result for is positive of a value of 0 is that we get a message that says x is negative. So if we want to then have multiple different conditions, then we use something called an else if or an elif, the way that this is written in Python. So you can see the result down, or the example down here. So we have if x is greater than 0, then x is positive. Else if x equals 0, then we have print x is 0, else print x is negative. So the way that these work is that only one of these branches is possible. So as soon as we get to a statement that evaluates as true, the code beneath that is going to be executed, and then we're going to move on in the program. There is no limit on the number of elif statements that we can include, but remember, and rather there's an optional else clause, but has to come at the end, because if it comes somewhere in the middle, then that is the statement that's going to be executed. Because remember, only the first true condition gets executed in this sort of multiple choice or this chained else if statements. If we want to repeat our code, if we want to repeat our instructions, there are any number of reasons that we might want to do that. Then we have two different kinds of loops that we can use, the while loop and the for loop. So while loops are doing something while a statement is true. So here we see there's a function I'm defining called countdown, where we have while some value is greater than 0, print n, do something else, and then at the end of that, once we have finished with our loop, we print something called blast off. When that statement is no longer true, so when n is no longer greater than 0, we stop counting, or we stop doing our loop, and we move on to the next statement in the code. The body of the loop needs to change at least one variable. Otherwise, we're going to end up with an infinite loop, which is not something that we want to have to deal with. So in here, you see that I have a value n that is being passed through. We're checking the value of n at each step, and at each step we are subtracting one value, or we are subtracting 1 from the value of n. And the way that we can write this in shorthand in Python is minus equals. So this is another way of saying n equals n minus 1. So all we're doing is we're just sort of writing a shorthand here. You'll also see plus equals, which is just an equivalent of, in this case, n equals n plus 1. So we're just incrementing by 1 or incrementing by minus 1. The next kind of loop that we have is a for loop. So a for loop iterates a predetermined number of times. So we're, in this case, iterating over a list, and we're printing just each of the different elements of the list. So it's the way that this is written is, in this case, for I in my list, so I is short for item in this case, print that item to the screen. So any iterable that we've seen so far, so this includes lists or tuples as well as strings, can be used in a for loop. We can also use a function called range in order to set a number to count over. There are a lot of different options that we can use, but the basic takeaway of this is that a for loop is something that is iterating a predetermined number of times. A while loop is iterating only while some statement is true. So what happens if we want to stop going through a loop? What happens if we hit some condition that says, okay, we don't need to continue, we want to move on to the next step? Then we can use something called break, which actually stops the execution of the loop. So if I modify my countdown function here to say that if n is equal to 2, then we're going to print countdown stopped, and then we break, which breaks us out of the loop. We don't continue on to the next value once we have reached this this value of 2. And if we look here at calling countdown of 5, you see that we start at 5, count down to 4, 3, and then we've reached our 2 value, so we stop. The other way that we can break out of a loop is with something called continue, which is going to stop execution of this iteration only. So one very simple example that I have here is a function called print evens. So we put in a value n, and then for each of the values in the range of that value, we are going to take the modular, or the value of that item, or that we're going to take that value mod 2, so modular arithmetic, and wherever that is equal to 1, we're going to continue, so we're not going to print that because it's not an even number. And whenever that is not true, then we will actually print the value. And you should see here that in the example down below, when we call this on a value of 10, we get 0, 2, 4, 6, 8, which are all of the even numbers less than 10. To sum all of this up, we usually want to control the flow of our programs to either skip or repeat instructions, or to choose which instructions to run based on the condition of the variables in our program. We can control flow in a number of different ways, using, for example, comparison and logical operators, conditional statements, and loops. And these are all things that you'll get some experience looking at in this week's practical, as well as in the weeks to come. So that's all I have for this lesson. I hope you found it interesting, and if you have any questions, please don't hesitate to post them to the discussion forum on Blackboard. Thanks. Bye.